We're told in this problem, three consecutive terms of a geometric sequence are x, x plus 7 over 2, and x plus 3. And we're asked to determine the value of x. So let's think about how to figure this out. Well, since x plus 7 over 2 and x plus 3 are consecutive terms of a geometric sequence, we know for a geometric sequence that if we take t sub n plus 1, if we take the n plus 1th term and we divide that by the nth term, well, that should give me the common ratio. So let's say I take the second term and I divide that by the first term. Well, that's going to give me the common ratio. And if I divide the third term by the second term, that'll give me the common ratio as well. And if I divide the fourth term by the third term, that'll give me the common ratio as well. So here we can, since we know that these are three terms in a geometric sequence, we know that the ratio of x plus 3 divided by x plus 7 over 2, well, that has to be equivalent to x plus 7 over 2 over x. So now we've got an equation. We know that these ratios are equal because we have a common ratio in a geometric series, or in a geometric sequence rather. So now we can go through and we can solve this equation. If I multiply both sides of this equation by x, I get that these factors of x divide out on the right side. If I multiply both sides of the equation by x plus 7 over 2, I get that the factor of x plus 7 over 2 on the left side divides out. And that's what I'm left with. Let me write that out actually. So I can multiply actually let's do this in several steps. Let's write this as x. If we distribute x into the numerator, I've got x squared plus 3x divided by x plus 7 over 2. And that's equal to x plus 7 over 2. Now I can multiply both sides by x plus 7 over 2. And if I multiply x plus 7 over 2 by x plus 7 over 2, I just get x plus 7 over 2 squared. These factors divide out. And we have to consider that now I have the restriction that if I have that x is equal to negative 7 over 2 or 0, those solutions are going to be extraneous. So x cannot be equal to negative 7 over 2 or 0 because those values of x would mean that the original equation is extraneous. So they wouldn't satisfy the original equation. So now I have that x squared plus 3x, well, that's equal to x squared. If I actually expand this out, if I actually square this binomial, I get x squared plus 7x plus 49 over 4. And if I try to solve this equation, well, I've got an x squared term on both sides. So those terms add to 0. And what I'm left with is that negative 4x is equal to 49 over 4. So the quadratic terms drop out in this equation. So I get the negative 4x is equal to 49 over 4. I can divide both sides of the equation by negative 4. And what I'm left with is x is equal to 49 over negative 16, which simplifies to negative 49 over 16. Remember that when you have a fraction with a negative in the denominator, with a negative factor or a factor of negative 1 in the denominator, always assign that factor to the numerator. So we have that x is equal to negative 49 over 16, and we're done.